Hi, geometry students. These notes are on the midpoint formula. So the idea of the midpoint formula, it's going to kind of fit into our unit similar to the distance formula or the slope formula, in that it's going to allow us to, in the coordinate plane, find the midpoint of a segment, and that's going to allow us to do different things with quadrilaterals, like show that they're congruent, or show that it's like a quadrilateral is a parallelogram by the diagonals bisecting each other, right? So this is a very useful formula, and we're going to kind of see how it comes to be. So first of all, remember that the midpoint of a segment is the point that is equidistant from both endpoints. So we're going to fill in the word equidistant here. From both endpoints of a segment, so that means that AM is congruent to MB. If M is the midpoint. We can also mark up the diagram like that. So if we're going to kind of think about how can we create a formula to find that point. So suppose in this example we have the line segment CD, and we're going to try to think about, first of all, visually, can we figure out where the midpoint is? So I want you to pause the video and just place a point somewhere on the segment where you think the midpoint is. And I'm going to then, so pause, press play once you've done it, and then we'll kind of continue the discussion. So when I look here, it looks to me like the midpoint would be right there. How do I know that's the midpoint? We can kind of discuss this idea in class. There's more than one correct answer for that. One way of thinking about it is I kind of see it as like to go from point C to point M, I go down 1 and over 2, right? While to go from point M to point D, I also go down 1 and over 2. So we can kind of then see there are these two little right triangles that would have the same length hypotenuse because they're the same size triangle, right? So if they have the same hypotenuse, you know that the distance from C to M is the same as the distance from M to D, so M must be the midpoint. So I'm just going to jot down that idea. So we can see that it can form two congruent right triangles, and then we could see that they have the same hypotenuse length. Now remember that to find the hypotenuse length you would do the Pythagorean theorem, but that's the same thing as doing the distance formula, right? So you could also just check by using the distance formula. We're not going to do that right now. We'll say you could use the distance formula to check. Okay. So the big idea here is, and I don't know if you guys can see it, but like if I want halfway between point C and D, and I'm going to kind of draw, so like if I draw the big kind of right triangle that goes from point C to point D, I'm trying to use a different color, hopefully it shows up. Notice that like the change in x from C to D is 2, and to get to the midpoint it's only 1. So essentially we did like half the vertical distance. So I may have said x, but I meant y. Half the vertical distance from C to D. So that would just be going down 1 instead of going down 2. And similarly, half the horizontal distance. So the horizontal distance from C to D is 1, 2, 3, 4. So instead we're gonna like split 4 in half and get 2. Another way of thinking about it is that the x coordinate here should be halfway between the two x coordinates here, and the y coordinate here should be halfway between the two y coordinates, right? So if I want the x and y values halfway in between, I want the average. So we're going to use averages here. So it says, I'm going to kind of reveal the formula now. So it says, suppose one is given the coordinates of the endpoints of a segment. Suppose they are x1, y1, and x2, y2. So similar to like a slope formula when we're thinking about x1, y1, x2, y2. In order to find the coordinate of the midpoint, we can use this formula. So the idea is you would add up the two x values and divide by 2, and that's going to give you that middle x value, the x value that's halfway in between the two, or the average x value. So this would be like the average of the two x values And then y2 plus y1 divided by 2 would give you the average of the two y values. Okay, so let's see how this will work in action. So we're given a graph of a line segment, and we can identify the two endpoints. So this first endpoint over here is 1, 2, 3, 4, 5. So it's negative 5 for x, and then up 2. The second one is over 2 and up 1, 2, 3, 4. So 2, 4. So if I want to know the coordinates of the midpoint, I'm using this formula. So I would add the x value. So I'm going to kind of write it in the ordered pair notation. So I'll have negative 5 plus 2. Now that 2 is the 2 from over here, not the 2 from over here. Divided by 2, comma, then I'm going to be adding the y. So this 2, comma, this 4, or sorry, plus this 4 over 2. And if you're confused on the setup, sometimes it's helpful that underneath like your coordinate we can write, let's call this x1, let's call this y1. Let's call this x2, let's call this y2, and then you're just plugging in. So from here I just need to simplify. So I know that then negative 5 plus 2 is negative 3, and I know that 2 plus 4 is 6. So now, further simplifying, I could leave like negative 3 over 2, that can't be simplified, but I could write it as a decimal, so in that case it would be like negative 1.5, comma, 6 divided by 2 is 3. Okay, now to check my work, I could plot this point and see if it looks like the midpoint. I'll know I'm off, first of all, if it doesn't even fall on the line, but then second of all, if it doesn't look like it's halfway in between. So if I go over 1.5 and up 3, that gives me that point right there, and that does look like the halfway point, so I think we did our work right. Okay, so if you flip to the back now, what I want you guys to do is pause the video and do this U-try problem. It's going to be really similar to the one we just did. I'm giving you the two coordinates, so we can use those as x1, y1, and x2, y2. Okay, and then we can check answers in class next time I see you. So pause the video, press play when you're ready to move on after you've completed the first U-try. So the next example we're going to look at is a slightly different kind of problem, but still related to the midpoint formula. So it says, suppose a segment has one endpoint with the coordinates 3, 9, and a midpoint whose coordinates are 10, 5. So it's giving us the midpoint in one of the endpoints, and it says, what are the coordinates of the other endpoint? So we can try to visualize this. I'm not going to kind of accurately plot these points, but I'll just kind of put them somewhere on my page. So let's say this is the point 3, 9, and then the point 10, 5 maybe, so it's like further to the right, but lower down, because 5 is less than 9. So maybe I'll put it like right there and say, like, let's call this 10, 5, which is my midpoint. Well, the idea would be like, that means that there's some other endpoint that's kind of like, I'm just kind of eyeballing it here, that's my x2, y2, but I don't know what the coordinates are there, and I'm trying to find them. So we're still going to use the same formula, but we're going to kind of take one piece of it at a time. So I'm going to start by thinking about finding x2. So to find x2, I would set up x1 plus x2 over 2, which would be 3, and sorry, I got distracted because someone just tried to come in, but so x1 plus x2 equals over 2, and the idea is like that should equal the x value of the midpoint, which I know is 10. So I should set that equal to 10, and I can also plug in, I know x1, because this is x1, y1. So I know x1 is 3, so the idea is I have 3 plus something, I don't know, call it x2, over 2 equals 10. And this is an equation I can solve. So I could, if I want to get x2 by itself, I would multiply both sides by 2, so I get 3 plus x2 is equal to 20. So the step I didn't show, but I'll show it, is times 2 here to cancel out that 2 on the bottom. Then I would subtract 3, and I get x2 must equal 17. Same idea to find y2. I'm going to use y1 plus y2 over 2 and set that equal to the y value of the midpoint, which is 5. And I'm also going to plug in for y1, 9. So we have 9 plus y2 over 2 is equal to 5. And then the algebra we're doing here is going to be exactly the same kind of as what we were doing up here. So I'd multiply both sides by 2. Then I'm going to show my work over here. I get 9 plus y2 is equal to 10. Subtract the 9 over, and I get y2 is equal to 1. So now I know that my midpoint is going to be the point 17, comma 1, where I put these two pieces together. Okay, so for the second you try problem, you guys are going to do something really similar to that. So you're given your coordinates of the midpoint, and you're given the coordinates of one of the endpoints, and you're finding the other. So we're going to plug in x1, y1 from the endpoint. We're going to set those equal to, we'll use the x coordinate here, and we'll use the y coordinate here. Okay? So do the best that you can on that, and again, we'll be checking on this next time I see you in class.